In section 12.4, we're looking at volumes of prisms and cylinders. If we start off, since this is our first section looking at volume, a couple things we need to be aware of. First off, the volume of a solid is the number of cubic units contained in its interior. Now this is different than what surface area was. In surface area, if we look at this object, we looked at the area of all the surfaces combined, and it had its own set of formulas. For volume, we're going to look about the amount of space it takes up. Cubic units are the units that we use, so it's going to be inches cubed, feet cubed, and we look at it, but it's that space in the interior. Our first postulate says the volume of a cube is the cube of the length of its side. If each side length was 1 here, I would say it's 1 cubic unit, which relates back to this. If it was 2, I would do 2, 2, and 2, so I could do 2 cubed and find its volume would be 8 in that case. Postulate 28, if two polyhedra are congruent, then they have the same volume. So if I have two prisms or pyramids that are the exact same in congruence, everything matches up, their volume will be the same. And the volume addition postulate says we could combine volume. So maybe we have two parts together, we could combine them and get a total volume. So our first one we're looking at is a prism. And for the volume of a prism, it's going to be the area of the base times the height. Now, I have a triangular prism here because we don't want to get too stuck in the fact of the rectangular prism, which has its own example, but we have to be aware it's the area of the base times the height. We always have to go back to that. Even though it may be easier on some other solids, like the rectangular prism, area of the base times the height. I want to figure out what that area is and multiply it by how tall the shape is. Now the height again is the distance between the bases, so I actually have two bases in the prism. My height is there and base area is that base. Now if it was a triangle, it would be 1/2 base times height for its actual area, and when we talk about that, we're talking about the base and height in the triangle itself. That's why it's a good habit to draw the base off separately, identify what we need from that, and then we'll plug it in. For a rectangular prism, we have a more general version. Now, if we look at our prism here, we could say its length and width is the dimensions down here of an actual rectangle down here. So I could do length and width to give me the area of the base, times the height to give me the height of the prism, which ultimately means I'm multiplying all three of them, which kind of relates back to what we said with a cube. With a cube, it would have been the values cubed, but if there were different values and it was a box or a prism like that, we could still multiply the three values. But we have to be careful because it still is area of the base. I wouldn't sit there and multiply all three values if it was a triangle. So let's do a few examples here. First we have a rectangular prism. My volume is going to be the base area. So my base is here. 30 times 25 times the height. Now 30 times 25 is 750. Times 10 gives me 7,500 centimeters cubed. Now to find the area of the trapezoidal prism we have, we're still going to do the same idea, but this is a good check to make sure we're not sitting there just multiplying all three values. So the volume is the base area times the height. Well, I can see that the height is 5. That's how far apart the bases are. If I draw the trapezoid off to the side here, I have 6, 14, and 3. I have to find that area separately. Now the base area, or the area of a trapezoid, is 1/2 the height times base 1 plus base 2, which is 1/2 times 3 times 6 plus 14. Well, 6 plus 14 is 20. Half of that is 10, so I would actually get 30 for my area of the base area of the trapezoid. So now I come down, it's 30 times 5 gives me 150 centimeters cubed. For the next one, our triangular prism, our base is this triangle here. Even though it's tilted on its side, we have to recognize that that is the base. So we're looking for the base area times the height. The area of our base, since it is a triangle here, is 1/2 9 times 12. Half of 12 is 6. 6 times 9 is 54. Our height is the distance between the bases, even though that's not a height the way we look at it. It's not 9. It is 18 because that's how far apart the bases are. So 54 times 18, multiply those together, and we get that the area is 972 centimeters cubed. Final one, we need to find the volume of a square prism. So the base is a square, where the length is 5 for each, so we mark them each as 5, and our height is 12. So since our base is a square, we know the base area is 5 squared, or 25. So our volume, base area times height, is 25 times 12, which comes out to be 300 feet squared. Next up, we're looking at the volume of a cylinder, where we had the same idea that the cylinder is that circular version of a prism with a circle as the base. It's going to work with the same idea, because the volume we had for a prism was the area of the base times the height. Well, in the cylinder, we want the area of the circle, since that's our base, times the height. But as opposed to a prism, which could vary in what the base is, in a circle, we know it's pi r squared. So there's our formula for the volume of a cylinder. We need to find the radius, square it, multiply it by the height, and by pi to get our answer. Just something to look out for. Make sure you don't accidentally choose diameter. You always want to make sure it's radius. So you may have to, if given diameter, set it up so take half of it so you do get the radius. So an example, let's write our formula out first. It's pi r squared times height. Our radius is 7. Our height is 12. We plug that in and we get 49 times 12 times pi. 49 times 12 is 588. So we get 588 pi centimeters cubed. Next problem, we're looking at the volume of a right cylinder is 684 pi cubic inches and its height is 18 inches. So here we're actually looking for the radius. So we plug our formula in. We know volume. We know height. We're solving for r. Now, one thing I would do as I start this problem off is I would divide both sides by pi. If I divide both sides by pi, it becomes just that, and we don't have that pi there anymore on either side. Since it's on both sides, we can divide both sides by that value. Now I'm going to divide 684 by 18, and I get 38 equals r squared. Then take the square root of 38. We could just write root 38 or square root 38. If we look at 38 real quick, 38 is 2 times 19. Doesn't look like we'll be able to reduce it, so our radius is the square root of 38 inches. If we approximated that with our calculator, it's about 6.16 inches. Okay, a couple more examples. Now we're going to look at, well, let's do the volume of the cylinder first. Let's go back, do one of those, and then we'll talk about this type of problem. So our cylinder is pi r squared times height. Our radius is 2. Our height is 6.5. So pi times 2 squared times 6.5. I get pi times 4 times 6.5. Now 4 times 6.5 is 26. So 26 pi feet cubed. Okay, now we're back looking at our prism here, kind of a combination. And earlier in this video we talked about how we could combine volumes and get a total volume. So I could actually cut this prism right here, so it gives me a rectangular prism on top and the one on bottom. I'm going to find the volume of both of those and then combine them. So I'm just going to number them 1 and 2. If I look at prism 1, I know it's 1 goes here. The height of it is this 4. And I need the depth of it. Well, I don't have it anywhere here. It corresponds to the same depth we have in the bottom one, so that's going to be 2. For prism number 2, we have 5, 2, and 1. So the volume of prism 1 is the base area times the height, or since a rectangular prism, we can multiply all three values. So let's say 2 times 1 times 4, which gives us 8. The volume of number 2 is base area, 5 times 2 times the height, which is 1. So we get 10, with the total volume being 8 plus 10, or 18 units